Hello and welcome back to our digital electronics series. Today, we are going to explore the fundamental principles of Boolean algebra. Understanding Boolean algebra is essential for designing and analyzing digital circuits. Let's dive in. Boolean algebra is a branch of algebra that deals with binary variables and logical operations. It was introduced by George Boole in the mid-19th century. Unlike traditional algebra, which deals with numerical values, Boolean algebra involves variables that take on only two values, true, which we represent as 1, and false, represented as 0. The three basic operations in Boolean algebra are AND, OR, and NOT. The AND operation, also known as conjunction, results in true if both operands are true. It's denoted by the symbol, or simply by placing the operands next to each other. The OR operation, or disjunction, results in true if at least one operand is true. It's denoted by the symbol, plus. The NOT operation, or negation, inverts the value of the operand. If the operand is true, the result is false, and if the operand is false, the result is true. Boolean algebra also includes several laws and theorems that help simplify expressions and design circuits. Let's go over some of the key laws. The commutative law states that the order of the variables does not affect the result. For AND, it is A and B equals B and A. For OR, it is A OR B equals B OR A. The associative law states that the grouping of the variables does not affect the result. For AND, it is A and B, and C equals A and B and C. For OR, it is A OR B, OR C equals A OR B OR C. The distributive law allows us to distribute one operation over another. For N over OR, it is A and B OR C equals A and B OR A and C. For OR over N, it is A OR B and C equals A OR B and A OR C. The identity law states that any variable ANDED with 1 is the variable itself, and any variable ORED with 0 is the variable itself. A and 1 equals A, and AOR 0 equals A. The complement law states that a variable ANDED with its complement is 0, and a variable ORED with its complement is 1. A and not equals 0, and a OR not equals 1. De Morgan's theorems are particularly useful for simplifying complex Boolean expressions. The first theorem states that the complement of a conjunction is the disjunction of the complements. In other words, not A and B equals not A OR not B. The second theorem states that the complement of a disjunction is the conjunction of the complements. In other words, not A OR B equals not A and not B. Boolean algebra is the backbone of digital circuit design. By applying Boolean laws, we can simplify logic expressions, which translates to more efficient and cost-effective circuits. For example, in digital circuit design, we use Boolean algebra to minimize the number of gates required, which optimizes the circuit's performance and reduces power consumption. That's a brief overview of Boolean algebra and its significance in digital electronics. Understanding these concepts is crucial for anyone looking to design and analyze digital circuits. Thanks for watching. If you found this video helpful, please give it a thumbs up, subscribe to our channel, and hit the bell icon to stay updated with our latest content. See you next time.